All right, so we have two special cases. I'm going to label this special cases. It's kind of the special things that a graph can do. And our special cases, if you want a reminder of what's in here, are going to be if I have a line that's perfectly horizontal or a line that's perfectly vertical. And I'm going to use two different colors because there's two different special cases, but we only have one graph. So I'm actually going to color code mine so we could tell them apart. You can just use a highlighter or something if you want to kind of match what we're putting over here with the line that's on the graph so that you know which thing goes with which line. Here's one of our special cases. An equation looks like this. And this one isn't too bad because we've actually been working with this already. If I gave you an equation like that, we said normally we need the y-intercept and then the start value, right? This does have a y-intercept, or not the y-intercept and the start value, the y-intercept and the slope, I'm sorry. This does have a y-intercept and it does have a slope. We just have to realize what they are. What is my y-intercept? 2. Okay, well, I just used the 2, and that was the only thing in the equation. So what's my slope? 0. So remember, I'm going to put this in a different color since it's hiding. There's a plus 0x there, but we don't write it out because adding 0 doesn't do anything. So this does have a y-intercept and a slope, which means I can graph it kind of like my other ones. There's just one thing that's a little bit different that makes it a special case. This starts off like normal. The first step would be to put the y-intercept on there. So I put the y-intercept at the beginning at 2, right? Now here's the part that's a little bit different. If I have a slope that's 0, am I going up and down at all? No. So I don't have to worry about this up and down and sideways business that I normally have to worry about because the slope's 0. If I'm not going up and down, what's that going to do to my line? Yeah, 2, 2, 2, 2, 2 the whole time. It's just going to stay 2. So it would just end up being a horizontal line. So that's one special case that you have to recognize is that if I have a slope of 0, it's just going to be a horizontal line wherever the start value is. Now, there's one other special case. That's our straight up and down vertical line. The last thing we're going to put in here. So you've seen equations like this. We've been working with these y equals a number equations where the slope is 0. The vertical line you have not seen the equation for until now. I'm going to talk to you and show you what it looks like. So this is a different equation. I'm going to put a vertical line. I'll put it going through 3 on the x-axis. So I'm going to put my line like right here. So this is our last special case. I'm using a different color just so we can tell them apart. Okay, we need to think for just a second. You guys told me a few minutes ago that the start value always goes on the y-axis, right? Is this blue line ever going to touch the y-axis? Nope. So that means it doesn't have a start value because it never touches the y-axis where the start value is. So there's no start value. And let's see what you guys remember. If I give you a line straight up and down like this, and I said, what's the slope? What would you tell me?
Error. B.
Not unidentified. You're close, but let's get the right vocab. Undefined. There we go. If you guys remember, we talked about the fact that because going up and down like this forces you to divide by 0, and dividing by 0 breaks the rules of math, so there's no number for the slope. So this literally has no number for the slope and no number for the y-intercept, which means I'm missing both of the things that I would need to fill into my equation outline. So I can't use the regular equation outline because I don't have the information I need. So the equation for this looks totally different. all of our other equations are y equals something. So they're y equals 3 minus 4x, or y equals 2. So all of our equations that have a slope and a y-intercept are all y equals something. So using that outline. This guy, here's what the equation looks like. So first of all, I'm going to make a little note. This has no slope and no y-intercept. So I have to use a different type of equation. So what we do for the equation is we just say x equals. Notice that it's an x and not a y. That's the way that you could spot that up and down line. It's the only equation that says x equals instead of y equals. X equals 3. Because where does it touch the x-axis? So that's what we do for the equation for that, since we can't use a normal outline. So this 3 is just where the line crosses the x-axis. So where the line crosses the x-axis.